you've always had variables in like the polynomial, in like the actual equation, right? But now we're actually going to have variables in the exponents. So here we have a variable up here in the exponent. How do we solve for that? Well, we kind of did this in grade 11 in 20-1 when you guys did sequences and series, and you did geometric sequence, or geometric series, and you had like a variable exponent. Your teacher would teach you how to find the common base of it, and then you could solve for the exponent. We kind of led you into this and taught you it in grade 11 in very first unit, so your brain may not remember it, but we did teach you this already in a very small, tiny lesson in geometric series when you were, when you were summing up geometric sequences. Okay, so if I want to solve for a variable exponent, the very first thing I'm going to ask myself every single time, and right now you're only going to ask yourself this because it's the only way you know, but then I'm going to teach you 2 other ways when you can't get common base, how you do it. Then you use logs. People will turn to that right away. Always ask yourself, if it says solve and there's a variable in the exponent, always ask yourself, can I make them a common base? If you can, that is the fastest way. Now you'll only do that because that's the only way you know. But once I teach you when it's not a common base, you're going to try and use logs all the time, when in reality this is faster, and you won't spot that it's a common base anymore once I teach you the other way. Okay? So always look for common base. When solving for a variable exponent. There's also something else that I see here. I have an equal sign. I have one variable. How can I solve this? Equal sign, one variable. How can I solve this? That's what we're going to do, but how can I solve it quickly? Y1, Y2, and find the intersection. Right? Every single time. You guys have to have that embedded in your head because sometimes they're just testing whether you can use your calculator. So you can go Y1, Y2. You could even move the 8 over by subtracting it, set it equal to 0, and then Y1, Y2. Like you can rearrange these equations all you want, and then Y1, Y2 them. It still works, right? But you have to remember the moment you have one variable and an equal sign. So if there was another variable in there, if there was like an X and a Y, you couldn't do it, okay? But if there's only one variable, you can Y1, Y2 this. So we're going to test every single time. We're going to do it by common base because often they'll say, where did he make a mistake with these questions? That's a common thing that gets asked on these ones, where they make a mistake. So you can't just Y1, Y2 them. But you can check your answers with the Y1, Y2 every single time. And on your test, you'll have one of these, but it'll be a written response. You'll have to be able to solve these properly. So you can't just Y1, Y2, which a lot of people try and do. Okay? So you need to be able to solve them properly. So we're going to solve it properly first. We're going to check with our calculator. Solve properly first, check with our calculator. So the very first thing you want to do is isolate the power if necessary. So you want to get it by itself. So it's over here by itself. Write each side of the equation with the same power. Same base. I don't know why that says power. That's stupid. With the same base, not power. That's a typo. Okay. So you have to spot that these are the same base. That's the thing that you have to be able to spot. Can I turn them to the same base? So 2 and 8, you can make the same base. Remember, the only way you can make bases is by raising them to a power, not multiplying. So some people will say 2 times 4 is 8. No, we're trying to make it the same base. So that means we're trying to raise it to an exponent. 2 to what exponent is 8? 3. That's correct. You can't just multiply, okay? So 2 cubed is 8. So we're going to 2 to the x minus 1 equals 2 cubed. All right. This is where people think I just tell them a rule that you can just cross them off and you set your exponents equal. The reason why you can get rid of the bases and set your exponents equal is because of this. Pay attention. If I said this to you at the very beginning of the lesson, I said 2 to the x equals 2 to the smiley face. What does x equal in order for this to be true? Smiley face. It has to, right? If this is equivalent to this, x and smiley face have to be the same thing. Do they not? Okay. So once you get common base, you can drop the bases off because if 2 to the this equals 2 to the this, right? This x minus 1 would have to equal 3 in order for that statement to be true, correct? So that is why we equate the exponents. It's not like you just everyone's like, cross off the base and make your exponents equal to each other because that's a step. Yes, it is a step, but you need to know why, because what if they do some sort of tweak on the diploma? What if they give you a little bit of a different type of question? This is why if you are a step person from grade 11 and all you come with is steps, is why grade 12 is way harder. Because we just tweak the question a little bit and you're like, my steps don't work, what do? I can't just directly fill it in. Like you have to realize, hey, I have to divide that 2 over and they match, right? You have to be able to work around, you have to know exactly why you're doing stuff all the time. So that when they give you a little tweak of a question, you guys can do it, okay? So the reason why we set the exponents equal to each other is because this exponent has to equal this one in order for this statement to be true. So now I can write my exponents equal to each other. X minus 1 equals 3. And then I can just solve. So x equals 4. Now you can check this every single time by actually just checking it to see if it works as well. But we can also check with our calculator, which we'll do in a second. So if we go 2 to the 4 minus 1 equals 8, this is a check. Remember, whenever you have an equation with one variable, you can put y1, y2. That's true. You can also check them by doing left side equals right side. Yourself, physically, algebraically, you can do that every single time. And you can walk away from the test crying, being like, I got it wrong. Or you can walk away from the test and be like, whoop, whoop, I got that question right. I'm good, I'm good. It really sucks if you just do the check wrong and think you got it wrong, though. That's a little bit of a faulty thing that can happen. So 2 to the 3 equals 8. 8 equals 8. You are happy. You walk away from this question. You're like, boom, I got this. Now, y1, y2. You're going to try it in your calculator. 2 to the x minus 1. If you have a TI-83 calculator, or if you have a TI-84 where the exponent does not pop up, if your exponent is a binomial, trinomial, anything other than a monomial, you have to put in brackets. So if I'm going to go put this into my calculator, I'm going to put in y1 as 2 to the power of x minus 1. So if your exponent does not pop up, you have to put your exponent in brackets. You have to. If your exponent pops up, yay, you get to that error you're not going to do because you don't have to worry about that error. But if your exponent does not pop up, you will error. Okay, you have to put this in. Because if you don't put the brackets in, your calculator thinks you're doing 2 to the exponent x and then subtracting 1 from that whole thing. That's what it thinks you're doing, which is not what you want it to think. And then your y2, you have 8. Now you're going to go second, trace 5, enter, enter, enter. If it says error, can't do, blah, 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 something like that, that means that you actually can't see the intersection on your graph. And if you can't see the intersection on your graph, the calculator can't calculate the intersection on your graph. Okay? So you have to be able to see where they cross in order for the calculator to calculate where they cross. So if you're asking it to find the intersection, but the calculator can't see it, you're asking it to do something it can't do. So you have to change your window till you can see where they intersect. Okay? So you should have gotten 4. Your normal negative 10, 10, 10, 10 window in this case would work. If your window is all wonky from trig, you can go zoom 6. It will send it back to 10, 10, 10, 10, or negative 10, 10, negative 10, 10, the zoom 6 button. Okay? And when you solve that, we're trying to find out what x equals, always, correct? We don't care what the y is on the intersection. We only care what the x is. Now, sometimes they'll ask a question like this. They'll say, solve this equation using your calculator. What is the value of y of the intersection? Even though x is the answer to this, they'll ask for the y. Yes, you really have to read closely, closely, closely. That's why I promote highlighters. I actually bought 3 extremely large highlighters. They're this tall and they're smelly. So if you really would like to have, they're in my other vehicle, but I bought them. They're like this big. They were $5 each. I expect them to be used. They were at the book fair at my daughter's place. I was like, yes, I want these. One's like apple smelling. One's like something else and something else. They're smelly. They really are. So I figured that might promote more people to use highlighters or at least steal those ones quickly. They're really large, so I was hoping they wouldn't get stolen for like the time. They would just be borrowed during class. It's pretty big. Like I think I would spot it, but it would like take up half your backpack. Like that. Just, this isn't yours. I swear, it's mine. This is my highlighter. No, it's not. Give it that. Okay? Scented and large. See? Promoting highlighting. Because so many people, I actually had a student yesterday who was writing his test, and the second time he called me over and was like, I don't know, like, what am I supposed to do? Which intersection? And then I'm like, It says the first time he's like, can I just have a highlighter? Like it was the second time I had to like underline something, being like, He's like, can I have a highlighter? I am skipping stuff. Okay. Good, good. Okay, B. Now, we get extents a little bit harder each time, okay? That's just how it works. Obviously, it doesn't stay exactly that easy, but it's not ridiculously hard. Now, how we trumped up here was this one was 2 and this one was 8, and we made one of them at least be the base that one of them was. This one's a bit harder because you have to spot 9 and 27 both have a base of what? 3. What's your question?
Can you just plug them into your calculator every time?
You can, unless it says algebraically, which I'm going to say algebraically. And like I said on the diploma, they'll do steps. Where do you make a mistake? You don't know where you made a mistake because you just use your calculator. Okay. So check with your calculator always. But if it was a multiple choice, sure. Okay. So 9 is, people say 3 times 3. No. We need 3 to the what? 2. We need an exponent. We're doing exponential equations. And then x minus 1. And I always put my exponent in brackets. Why do I put the exponent that's there already in brackets? Because you need to remember to distribute. The answer to you not distributing will be on your diploma. I promise you, because that is the common error. All right. 27 is 3 cubed. And then x. So do you see how you could accidentally not distribute? You go 2x minus 1? Yes. That answer will be on your diploma. It will be. I promise you. It's probably picked just as much as the right one. Okay? So we distribute. 3 to the 2x minus 2 equals 3 to the 3x. And now I have a base of 3. So that means that 2x minus 2 must equal 3x in order for this equation to make sense, correct? So 2x minus 2 must equal 3x. And then we just solve. When you have an x on both sides, just pick one and move it. I'm going to move the 2x to the 3x. And I'm going to get negative 2 equals x. Then I'm going to check it algebraically. 9 to the negative 2 minus 1 equals 27 to the negative 2. 9 to the negative 3 equals 27 to the negative 2. What's 9 to the negative 3? And this one. Why are these 1 over 729? Why isn't it just 729? It's negative. When you have that negative, they drop to the bottom to become positive. So this would technically be the same as 1 over 9 cubed, correct? 1 over 9 to the positive 3. That's why the 729 is on the bottom. And then once again, you could check y1, y2 in your calculator, but you would have to make sure that x minus 1 is in brackets if your exponent is not a pop-up. Okay? If you just have the little hat symbol and then your exponent, you have to put your exponent in brackets or you will never get it right. Okay? If your exponent pops up, yay. Okay, so we went from bases of 2, yes. Okay, we went from this one, we had to make both base 3. We go to this one. No, they're all really different and people just get a little sad. So this one is 16 and a half. Okay, when you see a fraction, when you see something to a negative exponent, we could make it a fraction. So when 9 to the negative 3, we can make it 1 over 729 or 1 over 9 cubed, correct? So if we have 1 to the 1 over 2, I can actually write that as 2 to the negative 1. X plus 4. I can bring any number from the bottom up by raising it to the negative 1. Because you took a negative 1, you moved it down to make it positive, right? So you can bring it back up and make it negative. Just like I have 9 to the 3 on the bottom here, I can bring it up and make it negative, right? So I'm going to distribute that. I get 16 equals 2 to the negative x minus 4. So I have to remember to distribute. And now we're back to a question just like the very beginning. I can make them both be base 2. 16 is 2 to the 4. Now I have base 2, so I can go 4 equals negative x minus 4. Add my 4. Negative x equals 8. X equals negative 8. And then I can check it. 16 equals 1/2 negative 8 plus 4. 16 equals 1/2 to the negative 4, which makes sense because I could bring that up, make it positive. So it'd be 16 equals 2 to the 4, which is 16 equals 16. So D is great. Later on, they're going to make it where D, this number 5 here, they're going to make it when we get into logs, they're going to make number 5 have an exponent as well. So it'll have an exponent, and the 2 will have an exponent, and the 4. And then you can't do this next step. But I like to call this the A value. This value here, if it doesn't have an exponent, what you need to realize is you can move it to the other side as long as this number doesn't have an exponent. If this was like 40 to the x plus 2 and I divided the 5 over, it'd be 1/5 times 40 to the x plus 2. The only reason why I can divide the 5 over is because the 5 and the 40 both don't have exponents. They both do not have an exponent. So then you can divide it over. If one of them had an exponent, you couldn't do it and you'd have to use logs, which we don't know how to do. So your homework today will have this be able to happen. Okay, so we divide the 5 over. And the reason why we have to divide the 5 over is because I can't make 5 or 40 be base 2, right? If I can't make them be common base, I can't do today's lesson. So there's got to be a way I can make it so that I can. So I divide the 5 over, and I get 2x equals 8, and then I can make them both be base 2. 2x equals 2 to the 3, so x equals 3. I am going to star this one with, if I could, 7 bajillion stars. No, but this one no one remembers.
I made a circle of stars around the area.
Because no one spots this as common base. If you have something equal to 1, you can always make common base.
Oh, yeah.
Because what's anything to the exponent 0? 1. So you just go to whatever the heck the other side of the equation is, take that base and raise it to the exponent 0. Done. So we're going to turn 1 into 6 to the exponent 0. Because 6 to the exponent 0 is 1, right? Can you see how you would forget to do that? Like, it's very easy to forget that one. But whenever you have anything equal to 1, you can make it be the base of the other side. So now we just have 2x minus 3 equals 0. 2x equals positive 3. X equals 3/2. Make sense? You see how I started that one because it's something that everyone would forget? Everyone forgets it.
It's so annoying. It's not that I'm cold or anything, because I don't know. I don't.
Everyone really cares too.
Can they hear me?
Oh, absolutely.
What up, boys and girls? I wonder if they heard my throat clearing.
No.
No?
Okay. So they probably did. Okay. So it gets a little bit more advanced. One more type that's more advanced. Okay. So last one, I could divide the 5 over because it was with a 40, correct? This time I can't divide the 4 over. I can't. Because I'd have a 4th in front of 2. I'd be no better off. Okay? But I can make them all be base 2. I can make them all be base 2. So this one is 2 already. 2 to the x minus 3. 4 is 2 to the what? 2 to the 2. Do you want to know where the common error is? People put 4 times 32 together. You can't put them together. The x is only to the 32. You can't combine these. They are not friends. You cannot make them join. So it's 2 squared, and then you're going to multiply that by 2 to the 5 to the x. Okay? So you have 2 to the x minus 3 equals 2 to the 2 times 2 to the 5x. Remember how I started this lesson off and I said to you the rules you need to know is if you have two bases that are the same and you're multiplying them, what do you do to the exponents? Do you know how many people write this as 2 to the x minus 3 equals 2 to the 10x? Do you know how they're going to have that answer on your diploma even though it's wrong? You have to. No, I would do the same thing on my tests. I would make that a common error because it's going to be where you're going to make an oopsie. Yep. 2 to the x minus 3 equals 2 to the 2 plus 5x. We have to add exponents. Now we have the same base and we can... Now we have the same base and we can set the exponents equal to each other. So we have x minus 3 equals 2 plus 5x. We're bringing back the solving equations from 9 and 10. Take an x to move it. People will sit here for forever and be like, I don't know what to do now. Just take an x, commit yourself, and move one. Okay? Pick one, move it. So you get negative 3 equals 2 plus 4x. Subtract 2. Negative 5 equals 4x. Divide by 4. And x equals negative 5/4. Now, we can still check this. We could take the negative 5/4, plug it in, and see if the left side equals the right side. Correct? Same thing. Didn't make it any different. Now, why is 2 a little bit harder? Because the 1/9, the very first thing I'm going to do is take that 1/9 and write it as 9 to the negative 1. That is how I'm going to fix this issue. The very first thing I'm going to do. So I'm going to write this as 9 to the negative 1, bracket x plus 1. And if my exponent is more than a monomial, I have to put it in brackets. Equals 3. If you want, so that you catch yourself so you don't make errors, write this 3 to the exponent 1. Because that often will get people to stop trying to put it with the 81. You guys will slide these together. That's going to be a common error. Do not do that, please. Please do not put those together. That happens so often. It's just sad. Do it. And then you have 81 to the 2x plus 1. So now we have 9 to the negative x minus 1 equals 3 to the 1 times 81 to the 2x plus 1. What base can I make them all be? 3. So 9 is 3 squared to the negative x minus 1 equals 3 to the 1. Please make sure you put 3 to the 1. So many people put 3 to the 0 because it doesn't have an exponent. 3 to the 0 is actually what? 1, not 3. Okay? See how that's another error where people make mistakes? I can easily come up with the 3 most common errors and make answers B, C, and D on any multiple choice with these questions. So make sure you put it as 3 to the 1 because 3 to the 0 is 1. It's not 3. And then 81 is 3 to the 4. 2x plus 1. So you get 3 to the negative 2x minus 2 equals 3 to the 1 times 3 to the 8x plus 4. When you have common base and you're multiplying, what do you do with your exponents? Add them. 3 to the negative 2x minus 2 equals 3 to the 8x plus what? 5. Because you're going to go 1 plus 4. Now I have the same base. So I can just set them exponents equal to each other. 2x minus 2 equals 8x plus 5. Add 2x. Negative 2 equals 10x plus 5. Subtract the 5, so negative 7 equals 10x divided by 10. Last one, number 3, very small space. Not quite sure why I made it so tiny, but I did. So if you're doing number 3, you might want to like do it at the bottom of the page or something. If you have printed these off, sorry. It's super tiny. Root 8 equals 2 times 16x plus 1. Everyone notices that they can change these to all to be base 2. They're just like, oh crap, what is the root 8? Why is it there? And why are they trying to ruin my lives? That's what you're thinking. Remember from grade 10, we went in grade 10 and we changed radicals to exponential and exponential to radicals. It was a whole lesson on it. Okay, and then you did mixed radicals, you did entire radicals, you did all those things in grade 10. So let's go back to that. You don't have to write this, just to pay attention. So if I had, say, the cube root of 2, let's say, what is 2 to the exponent of if it doesn't have an exponent? Not 0, it's to the exponent 1. All you do is you can change this radical to an exponential by drawing a line under the exponent and bringing the index underneath. So this is actually equal to 2 to the third. So the cube root of 2 is the same as 2 to the third. What index do I have on this 8? 2. Because if there's nothing written on it, I have a 2. If there's not an exponent, what is the exponent? 1. So I can just draw a line underneath the 1 and drop the 2 underneath. So what is actually the square root of 8 the same as? 8 to the power of a half. And then life is a little bit better than it was before. 2 is 2 to the what exponent, so I don't mess up? 1. What's up?
How'd you get square root 8?
It was the question up here, sorry.
Oh.
It's number 3. There's like no space. So then I'm going to make them be base 2. So this is 2 cubed to the half, 2 to the 1 times 2 to the 4 to the x plus 1. This is 2 to the 3 halves equals 2 to the 1 times 2 to the 4x plus 4. And I get 2 to the 3 halves equals 2 to the 4x plus 5 because I add exponents, and then I can solve it. 3 halves equals 4x plus 5. Subtract 5. And you get 4x equals, I'm going to have to change that to over 10, 2, so it's negative 10 over 2 is negative 5, plus 3 over 2. So 4x equals negative 7 over 2 divided by 4. You're all like, I'm going to punch this in my calculator. I don't really care what you're going to do. I'm going to do it properly. Okay? Dividing by 4 is like multiplying by a quarter. So you're going to, if you haven't printed off the notes, that's fine. You're going to have to go to the notes. I want you guys to finish these for homework. 4, 5, and 6, and I have a few from your textbook. Because the more practice, the better you get. So the notes are on, keep going, there you go, are on Google Classroom. You can pull them off of there. We're in chapter 7 and 8 in our textbook for these 2 units. So the exponential unit goes very fast. We'll be done it on Monday. Okay? You do common base with exponential. You do transformations and graphs of exponential. And then we do word problems. And then we're going to move on to logs. Okay? Because the reason why we have to put the lessons together is because unless you get, right now, unless we have exponents with common bases, we're not going to be able to solve them. That's where logs come in. That's why the units go together. So, page 364. Number 4 to 7, odd letters. Odd letters, I know sounds stupid, but it's A, C, etc. 4 to 7, odd letters. And then numbers 4 to 6 in your notes.